Alright, I have little breaks in between classes today, so I will be able to do one more, I think, and tomorrow I'll come back and do the longest one. Alright, let me see. So, I think number 1 has parts A through D, so I'll do this one tomorrow. I'll do number 1 tomorrow during my planning day or office hour day. 3 looks a little bit shorter, so I'll go ahead and do this one. I couldn't be too creative with number 3, so, I tried to find similar problems in your textbook, but I really couldn't find one, so I just changed something minor about this, and I am going to go over this example. This should be similar to your number 3 on the application quiz. So let's see. It says, suppose that the demand equation for a certain commodity is given by P equals 100 over natural log of X. Determine the marginal revenue for this commodity. How do you do that? They gave you a demand equation and they're like, what's the marginal revenue function? So, I think you guys read about this section, this marginal revenue in chapter 3. You cover so many sections this week, so maybe I'll jumble. So I'll remind you, not marginal revenue, but revenue function, R of X, is equal to X times the demand function. And the demand function is 100 over natural log of X, huh? So the revenue function is X times this P of X, the demand function. Revenue is X times the demand. But that's not what they want. They want you to find the marginal revenue. So they want you to find R prime of X. So you have to take the derivative of this, okay? If I rewrite this, that's not much rewriting, but if I just put that X on top of the fraction with the 100, that is 100X over natural log of X. Let's take the derivative of this using the quotient rule, okay? So let's find R prime of X using the quotient rule. So when I'm using the quotient rule, I have to, I'll write down the quotient rule here. Quotient rule says, if you are taking the derivative of f over g, then the denominator is g squared, and the numerator is gf prime minus fg prime. Some of you have different ways to memorize it, but you know quotient rule from the first unit. So let's go ahead and plug in everything. So the bottom of the fraction was natural log of X. So in the marginal revenue function, the denominator is just going to be natural log of X squared, the original bottom squared. Now let's go to the top of the fraction. I need to start the numerator with the original g of x, the bottom of the fraction, which is just natural log of x, ln x times. I need to multiply this by the numerator derivative. So f prime is gonna be 100. Derivative of 100x is just 100. So I'll do that. Minus sign. Next one I need is the original numerator f, which is 100x. And I am multiplying this by what? The derivative of the denominator. What's the derivative of natural log of x? That is 1 over x, right? All right, let's simplify this mess on top. I can write 100 in front of natural log of x. So 100 natural log of x minus, now look what happened over here. This x cancels out with this x. So only thing that I have left is just 100. All over natural log of x squared. That looks good to me. I mean, we can use all sorts of simplifying skills, like we can factor out the 100, or even like make this 100 a denominator, the exponent of this log argument x, but I don't really think that is necessary. We don't really need to do that. So if you stop there, I would say that is a perfect answer. If you really want to factor out the 100, you may want to write it as 100 outside, natural log of x minus 1 all over natural log of x squared. And that is the marginal revenue function. That's the marginal revenue function that A was asking us to find. So in this problem, you needed to know two things. First, how do you go from a demand equation to a revenue function? So that is just x times the demand function. And after that, you had to know how to use a quotient rule to find the marginal revenue function, which is just r prime of x. All right, now next one, I bet we are using this function that we just wrote, right? So part B is asking compute the marginal revenue at a production level of 30 units. Okay, so they are asking us to find r prime of 30. And that's simple. Finding that is just easy. We just gotta plug it in. But the part is, let's practice interpreting this marginal revenue. Okay, and I'm just gonna use a standard interpretation of these marginal revenues and apply it here. But let's plug in 30 first. Okay, so I have 100 times natural log of 30 minus 1 as my numerator, and the denominator is going to be natural log of 30 squared. All right, we'll need a calculator to evaluate that, so I'll go open one up. Don't worry, this is nobody's grade. This is my test student grade. I'm not showing anybody a grade. Desmo's scientific calculator. So over here, let me type this work in. So I need, all right, hold on. Okay, 100 times natural log of 30 minus 1. You know what? It worries me. I'm going to put that log argument of 30 in a parenthesis so that they don't do 30 minus 1 and make it 29. So that's the numerator, and the denominator is natural log of 30 raised to the second power. So that's what I got. I got 20.7569. Like, that number doesn't really make any sense to me right now, but that's why we are going to write an interpretation of this number together. So this came out to be, now there was no rounding rule, so I'll just write down 20. Usually these are money, so I'll go ahead and write down 20.76, okay? And let's talk about this answer. How do you interpret marginal revenue? So you can write something like this. So the number that we plugged in was 30, right? So once 30 units have been, what's going on in this situation? What does X stand for? Produced, not sold, but produced. Once 30 units have been produced, the approximate revenue from the, one more, not 30, but 31st unit is, and this is, well, this is the marginal revenue, is how much? $20 and, oh my goodness, I wrote too big. Make this a little bit smaller, okay? $20 and where did my number go? 76 cents. $20.76. So that's how I would write the interpretation of the marginal revenue. After finding the number, make sure to add the interpretation. And this problem took us about 10 minutes. I have a class starting at 1 o'clock, so I don't think I have time to start number 1. But I promise to come back and go over number 1 and post the video on Canvas for you Thursday morning so that you have all similar examples for your application quiz 3D, okay?